All right, here we go with 4.4. Dogs are coming. Okay, 4.4. The first question, number 12. Let's see. All they want you to do on number 12 is check to see whether each x value is a solution of the equation. So on number 7 and number 11, well, you're doing, what are you doing? Number 7, you're just plugging in 5. Does that work? You're plugging in 2. Does that work? Yes or no? That's all. So that's just a substitution. And if you get 64 on that left-hand side, it worked. If it doesn't, then you didn't. But I'm going to do numbers 25, 29, 33. And those directions want us to solve the exponential equation. Now on 4.4 in either class, I didn't get a chance to really go over all of the notes, but here's the summary. Solving equations for whether they be logarithmic equations, and that's what you're seeing here, 2 basic strategies for solving exponential or logarithmic equations is the inverse properties or the one-to-one properties. If you have the same base on the one-to-one, or if you have the logarithm same base, the insides equal each other, the exponents equal each other. Once you get the same base on both sides, same log, same base, you can let the other parts equal each other. Or you undo a logarithm by raising it as the power to a base of a, or you take log base a of an exponential function to undo that x. Okay, so hang on. There we go. The summary, 4.4 is right here, and it gives us rewrite the original equation in a form that allows the use of one-to-one properties, rewrite an exponential in a log form, or rewrite a log in an exponential form. And there's 1, 2, 3, 4, 5, 6, 7, 8 different examples, 4 of each, of how you can use one-to-one or use inverses. And I'm just going to, basically walk you through some of the homework examples using the same ideas. Here we go. Stop on the share. And so you have 5 to the x on this side, 1 over 625 on that side. Now, hopefully you recognize that 625 is a power of 5. This is 5 to the x, and this is 1 over 625 is 5 to the 4th power. Now, you don't have 5 on both sides. The same base means they both have to be 5. So it has to be a 5 to the x, and this has to be a 5 to a power. So if you have 1 over 5 to the 4th, you can flip this up by making it 5 to a negative 4. Now you have the same base on either side. 5 to the x equals 5 to the negative 4. So this x is equal to that negative 4. Okay, 29. 2/3 to the x is equal to 81 over 16. Before you start thinking, oh, the only way to do this is logarithms, think about the bases. 16 is a power of 2. 81 is a power of 3. But 2 is up here in the numerator. That 16 is down below. So in other words, just like I did over here, 2/3. Don't flip this over because you don't want to change the sign of your x. 2/3 to the x, this is 3 to the 4th. And 16 is 2 to the 4th. It's just that your 2 and 3 are in the wrong place. So you can flip them by changing the power of the exponent. So 2/3 to the x power is 2 to the negative 4 over 3 to the negative 4 on this side. which means your 2/3, this base on the left, is equal to this 2/3 to a -4 power on that side. 2/3 to this equals 2/3 to -4. So this x has to equal a -4. Same base. The oddball here is 33. First of all, you cannot multiply 6 times 10 to the x. You cannot multiply these together. Order of operations, parentheses, okay, 10 to the x. You'd have to do parentheses, you'd have to do exponents before you can multiply 6 times. Since you don't know what x is, you can't multiply 6 times 10 to the x because you haven't raised 10 to the x power yet. So don't multiply and think this becomes 60. No way. Divide both sides by 6. So now you have 10 to the x equals 36. Now, 36 is not a power of 10. So writing it into a 1-to-1 setup is not going to happen where the bases are the same. You can't get a base 10 on either side, on both sides. So we want to convert the exponential equation into a logarithm equation. How about we take log base 10 of both sides, since that's a base 10. So you would take the common log of both sides. When you take a common log, you don't have to write the base, log base 10, log base 10. Log base 10 of 10 to the x is just x, and x is equal to the log of 36. Now the directions, let me pause and let me take a quick look. So elegant in the back of the book. In the back of the book, they have log base 10 of 36. And so I just want to make sure that you understand whether you put the 10, log base 10 of 36, or just write it as common log, log of 36, they're the same thing. If it's a different base, then you have to write the different base. All right, next problems. Okay, so in our next set of problems, number 37 and 45 that I'm going to do, we're supposed to solve the logarithmic equation. So what is x equal? Solving for that x right there. So here and then in 45. So again, 1-to-1 looks like this. I got to do a different share. One-to-one, where you have log on the left equals the same log on the right, same bases, or inverse properties. Those are our methods. There we go. You have two natural logarithms. They're exact natural logarithms. So you can take this and go, all right, this could be add the natural log of 5 to both sides. So on the left side, you have the natural log of that x. On the right side, you have the natural log of this 5. Since they're both the same logarithm, this x has to equal that 5. Okay. Over here, you don't have multiple logarithms. You have one logarithm equal to a number. So now we want to undo the logarithm. We want to use the inverse property, the inverse operation. So to undo a logarithm, you got to use it as an exponent for the right base. Since this is a natural logarithm, we're going to use that as a power for e. It's called exponentiating. We're going to exponentiate both sides as a power of e. E to this side and e to that side. You don't say you raise both sides. You don't raise both sides to the e power because you're not raising it to the e power. You're using each side as a power of e. E to this natural log of 2x minus 1 undoes the logarithm, and we get the 2x minus 1 equal to the right side, which is e to the 5th. And I've already looked, the directions don't want decimals. If they wanted decimals, they would tell you in the directions. So we want the exact answer. E to the fifth is the exact value of e to the fifth. So don't go punching stuff into a calculator just yet. To solve for x, add 1. So 2 times x is equal to e to the fifth plus 1. And then you can either divide both sides by 2. So x is equal to e to the fifth power plus 1 all over a 2. Or if you're worried about, does it go into each one? Do you got to worry about factoring, simplifying those things? You could divide each one by 2. And that would be 1/2 of e to the fifth plus 1/2 either way. Leave it like this or you leave it like that. They're both the same thing. But this is the exact answer for that x. Okay, for number 49, been in this spot before. All they want from the directions, simplify the expression. Simplify the expression. So we have e to the natural log of x squared minus 3. And it's actually going to take me longer to, if I would have written it on the board, to actually do the problem. Because the base is e raised to a natural logarithm, then the bases are the same. They undo each other. They're inverse functions. So the answer is just the insides, x squared minus 3. That's all. On 57 and 61 and 68 and 72 and 75 and 77, we're going to solve. And then they also want, in addition, round your answer to 3 decimal places. Okay. Round to 3 decimal places. So give me a quick second here. So that's a base 5. To undo a base 5, you would take log base 5 of both sides, but here's your problem. Okay. You know what? Give me a. I'm going to approach this 2 different ways. One, because I just saw something, but 2, you may not always see something. This is a very unique circumstance. So the first thing I'm going to do is I'm going to show you what it would look like if you just came across this question and you know you're supposed to get a decimal answer. Okay. So if I'm just walking up to this problem and I know we're supposed to round to 3 decimal places and we're dealing with 5 to the negative t over 2 is equal to 0.20. And so, all right, since I'm going to plug it into my calculator anyway, I need to make a decision. Do I want to use base 10 or do I want to use base e? Do I want to take common log or natural log? It doesn't matter. So I'm going to alternate. I'm going to take the common log this time, common log of both sides, because that's the only way to bring this exponent down in front. You have to undo the power. So I'm going to take log base 10 of both sides. So now this exponent, all of it is going to come down and you get negative t over 2 times the log of 5, the common log of 5, is equal to the common log of 0.20. Okay. So I have to move it over here. Because it's being divided by 2, I'm solving for t, it's being divided by 2. I'm going to multiply both sides by 2. Because it's being multiplied by negative common log of 5, I'm going to divide both sides by the negative common log of a 5. It's being divided by 2, t divided by 2. So I'm going to multiply both sides by 2. It's being multiplied, you have a negative times a common log of 5 times your t. So I'm going to divide both sides by the negative because I want to know what positive t is equal to. Divide by the negative and divide by the common log of that 5. So t is going to end up, this is what I'm going to punch in, a positive over a negative. So a positive divided by negative is going to be a negative. The log, common log of 0.20 over the common log of a 5, common log of 5. So t is equal to a negative. Now on my calculator, or your calculator, whoever's calculator, okay. Oops, didn't hit share yet. We're going to punch in the log of 0.2, common log of 0.2. That and divide by the log of 5, the common log of 5. And that's equal to -1. So this is -1. Oops, I forgot this 2 right here. There's a -2 times a -1, so the answer is +2. It really throws everything off if I don't bring that 2 over here. So the answer is +2. Where's the decimal? Well, that's just it. That actually doesn't have a decimal in it. And I'll show you why. Because what I saw earlier before I even started the problem, 5 to the -t over 2, 0.20. So when I first started this, I'm going, all right, wait a second, 0.2? 0.2 is 1/5. I can change that to a fraction. 20 cents is 1/5 of $1. So this is 5 to the -t over 2, and this is equal to 1/5 as a fraction, which means this is 5 to the -t over 2, and this is equal to 5 to the -1. This one can be written with the same base on either side. So this -t over 2 is equal to that -1. Multiply both sides by -2. And you get t is equal to +2. So that's only because that is exactly 0.2. If it was, 0.26, it's not going to work because 26 cents is not a perfect power of a 5. But this time it was. All right, let me get the other ones up here. Okay, 61 is next. 61 over here is next. So you have e to the -x, 500 times e to the -x. So if you were solving 500 times x, you would divide both sides by 500 first. So the same thing here. Divide both sides by 500. So e to the -x. And it really helps if you simplify this. 300 over 500 is just 3/5. Then to undo an e to the x, this is obviously not going to be a 1-to-1 equation where you have e on the same side on both sides. So you're going to have to take the logarithm of both sides to undo that exponent. Since it's a base e, we're going to take the natural log of both sides. This time we're going to use the natural log. Natural log of this side equals the natural log of that side. The natural log of e to a -x is that -x. Equals this side, the natural log of 3/5. Now you can go ahead and calculate the decimal right now if you want. You could divide both sides by -1 and just make sure you change the sign. I'm just going to keep going through here. negative x is equal to, and just keep track of my signs. So when you punch this up, make sure you keep track of things. Got a natural log of 3/5. It's a negative. So it's negative 0.5108. 256.238. And I'm sorry I did that off screen, so here I can show you very quickly. Natural log of 3/5. And then it's negative x equals that negative, so divide by -1. And your positive x is now positive 0.3 decimal places, so it's going to be 0.512, because the 8 rounds a 0 up to a 2. Okay, that thing is just an utter mess. I'm going to simplify what's on the inside of parentheses first, just like anytime you would do order of operations. Inside that parentheses, it's 16 plus whatever this fraction is. So it's going to be 16 plus this decimal. But remember, all of that is still to a 3t power. So inside on my calculator, I'm going to go 16 plus this fraction. This time I'll make sure I screen share. Just not used to doing the screen share. So 16 plus, we have 0.878 divided by a 26. Now, if you notice, I'm not putting it in a parentheses, even though normally my OCD makes me, but that's because order of operations. The calculator knows to divide the 0.78 by the 26 before it adds the 16, or at least it better. So that's the answer inside the parentheses. Inside the parentheses, we have 16.03376 923 equal to 30. Okay. Now what you have to do is to undo the exponent. Well, you don't have a logarithm base 16.03376.923. And remember, round at the end. Don't round it, throughout the process, because now your answer is not going to be as accurate. Round when you're done, when you get to your final answer. So I'm going to take, since I did natural log on the last one, I'm going to do common log on this one. I'm going to take log base 10 of both sides. And 10's not going to open because I got no hands. The common log of both sides. 3t, come on down. So it's 3t times the common log of 16.03376.923 equal to the log of 30. And to solve for t, t is right here. Put it in that different color would be nice. To solve for that t, it's being multiplied by 3 and multiplied by this common log of 16.03376. So I'm going to divide both sides. I'm going to divide both sides by a 3 and divide both sides by log of 16.03376.923. So t is equal to, this is where you need to be careful. When you do punch this in, you want to make sure it's all of your log 30 divided by 3 times this. So you either want to multiply this in your calculator first and then go log 30 divided by the last answer, or make sure when you type it in, use parentheses. Log of 30 divided by parentheses, those two multiply together. Okay, so it's my log of 30. So that number over a parentheses 3 times common log. And I can hit common log and type in the whole number, or I can just hit second and answer. And it's going to type in, it's going to put in the calculator for me. The last answer that my calculator got was the 16.0337. Okay. And then close the parentheses. Now, the reason why you have to have the parentheses, without it, if you just put log 30 over 3 times log of the answer, then from left to right, it would go log 30, divide by the 3, and then take that answer and multiply by the log of the 16. It wouldn't divide by the whole thing. Okay. So we get t equals 0.4085 968 413. 3 decimal places, t is equal to 0.409. It's got to be small. 16 to 3 times a number is a 30. Well, 16 to the first is 16. 16 to the second, 16 squared, is 256. So 3 times t better be small. It can't be more than 2, definitely, but it's got to be more than 1. 3 times 0.409 is about 1.2 something. Make sure you think it through. All right. 72, 75. They look very similar to each other, but they're completely different. Completely different. There is some recognition about what this kind of looks like. E to the 2x minus e to the x minus 6 equals 0. Something from our bag of tricks in chapter 2. When you don't like what this looks like, U substitution changes it into something we do like. This is e to the x to the first power, e to the x to the first power, or this is e to the x, a 2x is because it got squared. Power to a power, you would multiply. X times 2 gives me the 2x. So this is like a u to the first, and that's a u squared, u substitution. U squared minus u minus 6. And you could do the u substitution and solve. But let's try to think it through without the u substitution. Factoring, yes, it comes back for another extended engagement. First times first is e to the 2x. Well, the only way you're going to make e to the 2x is e to the x times e to the x. E to the x times e to the x is e to the x plus x. Because when you multiply the same base, you add the exponents. And that's how you get e to the 2x. This is e to the x squared, power to a power. You multiply. X times 2 is 2x. So e to the 2x is e to the x times e to the x. The sign, last times last is negative. Well, the only way we're going to get a negative, you got to have a positive times a negative. The last answer, the last term is a 6. Well, the only way we can multiply and make a 6 would be a 1 times a 6 or a 2 times a 3. Since we want 1 in the middle, negative 1 in the middle, we'd want negative 3 and a positive 2. Outside times outside is negative 3 e to the x. Inside is positive 2 e to the x. Negative 3 plus 2 is negative 1 e to the x in the middle. But we're not done. Once it's factored, you let each factor, you let e to the x plus 2 equal 0. You let e to the x minus 3 equal 0. And then you solve. To solve, subtract 2. So this e to the x would be a negative 2. And now to solve for x, to undo e to the x finally, you take the natural log of both sides. And you realize natural log of e to the x, natural log of a negative 2 is impossible. This factor right here gives us no solutions because you can't take the natural log of the negative 2. But this one over here, add 3. E to the x equals 3. Take the natural log of both sides. Natural log of e to the x is just x. The exact answer is natural log of 3. And then you can punch that up and write down the decimal. But that's the only answer that makes this work. Natural log of 3 is your x value. Versus this one, where you have the same base. That's an e to a power, and that's an e to the power. E to the parent, and if you need to, it's e to the whole thing, x squared minus 3x, and this is e to the x minus 2. Okay? So since the base is e on both sides, the exponents equal each other. This exponent, x squared minus 3x, has to equal that exponent, x minus 2. Because the bases are equal, the powers are equal too. Now that's in quadratic. When you solve a quadratic, make one side 0 and try factoring. Subtract x, add 2, x squared minus 4x plus 2 is equal to 0. That's not going to factor. And because it's not going to factor, you could either complete the square or use the quadratic formula. Let's see. I'm going to complete the square for good old time's sake. So isolate the constant. Leave a little spot where that constant was. Make sure it's 1 times x squared, and we got a 1 times x squared. Then I'm going to take half of the b, room to work here. So I'm going to take 1/2 of that negative 4, that's a negative 2. Then I'm going to square it. I get a positive 4. I'm going to add that to both sides. So I get x squared minus 4x. Plus 4 is equal to 2. This is now a perfect square over here on the left. So you factor this into x minus 2 perfect square equals 2. Take the square root of both sides. Don't forget your plus and minus. Square root. We get x minus 2 is equal to plus or minus the square root of 2. And then you add 2 to both sides. So we get x equals 2 plus or minus the square root of 2. So that, using your calculator, is either 2 minus 1.414 or 2 plus 4.414. 1.414. So 2 minus is going to be 0.8. No, 8. What am I saying? 8. 0.58. Oh, 6, 7. No. Oh my gosh, my brain is freezing. And I'll get a 6. 9. I'll get an 8. And I'll get 9. 5. There we go. Man, I should have just pulled out the calculator. My brain is done for the day. 0.586, and this one's nicer. This X is 3.414. Okay. Those are your two values. No logarithm necessary. Okay, 77. Hey, there's a denominator. I'm going to undo that denominator. Because I got to get that X from down below up above. So I'm going to multiply this whole thing by 1 plus e to a negative X. Over here, watch what I do. 1 plus e to a negative X. But you know, we're going to probably take a logarithm of both sides. You don't want to distribute the 350. Let's go ahead and divide both sides by the 350. You basically are looking at it like from this perspective. There's only one exponential piece of this entire, setup. So when you only have one exponential part, you can't set two, exponents equal to each other. You don't have two base e's. So you're probably going to have to take the natural log of one side and numbers on the other side. So let's go ahead and get our numbers on the other side. 350. Divide by the 350. So that is going to give me that 400 over a 350. I'll simplify that in a second. And over here, I just have 1 plus e to the negative x. Now this is 40 over 35, and that's 8 times 5 over 7 times 5. So this left side reduces to 8 over 7 equals 1 plus e to the negative x. Now, keep your wits about you about what you're going to have to do to solve for the x. Since it's a base e, you're going to take a logarithm, a natural logarithm, but not with a plus 1. You just want the e to that power here by itself. Subtract 1. Subtract 1 from both sides. You can't do it until you've got it in the numerator. You have to do the multiplication. You have to do that cross multiplication first. Then you can move it back to this side by subtraction. Only until it's in the numerator can you do addition or subtraction for both sides. 8 over 7, take away 1, would be 8 over 7 minus 7 over 7. 8 sevens minus 7 sevens. This is just 1 7 equals e to a negative x. If you want to go ahead and go decimal because you know you're going to end up, simplify rounding to 3 decimal places, that's fine. 1 7, punch it up as a decimal. But you should be able to handle these kinds of fractions. To undo this base e, natural log. Natural log. The natural log of e to the negative x, negative x. Over here, the natural log of 1/7 on the calculator. So natural log of 1 over 7 is negative 1 point, I can't see, 1.9459 101. I really need to see somebody about my OCD. 10149 and talking to myself equals negative x. And then divide both sides by -1. So x is equal to, rounding to 3 decimal places, positive 1.946. Okay. Okay, 96, 100, and then 106. So got a natural logarithm of 2x equals 1.5. We're supposed to solve for x, round to 3 decimal places. Well, you have a single logarithm and a number over on this side, so we want to undo the logarithm. You're going to exponentiate both sides using a base e. E to the natural log of a 2x is the only way to undo the logarithm. Out pops the 2x, and on this side, it equals e to the 1.5. Then raise e to the 1.5, and then when you're done, you're going to divide by 2. So x is equal to e to the 1.5, and then we'll divide by 2. So here. So in the numerator, e to the 1.5, all in a nice happy parentheses, and then take that and divide by a 2. And so I'm just for the sake of time, I'm gonna write down the answer. 2.4, see, it won't let me. 2.241. 2.241, 3 decimal places. Wow, I did it. Probably not gonna be able to sleep tonight. If you were trying to solve 3 plus 2, just 2 times t equals 10. To get t by itself, you subtract 3, then divide by 2. Same process. To solve for that x, subtract 3. 2 times the natural log of x is equal to a 7. And then divide both sides by 2. So the natural log of x, get the natural log by itself, is equal to 7 over 2. Go ahead if you want to change it to 3.5. It's an exact decimal. You wouldn't worry about rounding. To undo the logarithm, you're going to exponentiate both sides as a power for e. So e to the natural log of x is just x. And on this side, you're going to go e to the 7 over 2 or e to the 3.5. E to the 3.5. And I can do it again. 3 decimal places, so 33.115. Wow, breaking ground today. Okay, let me get 106 written up over there. Now, I've written up 106 twice because I want to show you 2 different ways, because I know from a perspective of sitting where you guys have sat or sitting, you look at this going, I don't know which way to go, which way to start, where do I go, where do I go? You know, one time you're bringing down powers, you're writing square roots as exponents, next time you're not. So I'm going to show you how both ways can work. This right here, if you just go straight to, hey, we have a logarithm equal to a number. So undo the logarithm. Natural log, you're going to exponentiate both sides using base e. E to the natural log of this square root x minus 8 is just the square root of x minus 8. On this side, e to the 5th power. Then, if I undo the square root, to undo a square root, you would square both sides. So you end up with x minus 8 equal to, be careful here, power to a power, you multiply. This is e to the 10th power. Then, before you punch it into your calculator, the answer is going to look like e to the 10th, and then you would add 8 to that answer. From this perspective, same question, but what we've been doing with that x minus 8, that square root, we've seen that it can be written as an exponent. It's a 1/2 power. Which means if you don't want to deal with square roots, you don't have to. We can bring this down in front, and it's 1/2 times the natural log of that x minus 8. Which means now, because of 1/2 times, you'd multiply both sides by a 2. So now you have the natural log parentheses of just your x minus 8 equal to 2 times 5, that's 10. Now you have your natural logarithm equal to 10. Exponentiate both sides as a base, as a power for e. So e to the natural log of x minus 8 is just the x minus 8. Over here, e to the 10th. And then the next step, like we did here, would be add 8. And we get the same answer either way, e to the 10th, and then add 8. You guys know how to punch that stuff in from now. Okay, I'm not going to punch all of them in. It's going to be huge though, because e to a 10 power, something bigger than 2, almost 3, 2 to the 10th is 1024. So e to the 10th is a lot bigger than that. And then add 8. Okay. Now I'm going to go back and talk about 100. I'm going to go back to it in a minute after I talk about this one. There's a connection here. In fact, hang on, time out. Okay. So I'm going to take this from 2 different perspectives here. For number 108, then I'll go back to talk about the 100. You have a natural log equal to a number. So it's time to use, raise both sides as a power for e. But I'm going to show you 2 different things because it's kind of connected to the last question we did as well. So I'm going to rewrite this. Natural log of x minus 4 squared equals a 5. Over here, natural log of x minus 4 squared equals a 5. Okay, as is, just exactly as is. You have logarithm equals a 5. So the base is e. So now it's e to the natural log of x minus 4 squared is just x minus 4 squared. And on this side, e to the 5th. We're solving, so you're going to take the square root of both sides. And you get x minus 4 equals, because you're solving and you took the square root of both sides, it's plus or minus the square root of that e to the 5th. Then you add 4. So we get x equals 4 minus the square root of e to the 5th. And we have x equals a 4 plus the square root of an e to the 5th. So that would be 4 minus the square root of e to the 5th. So e to the 5th, whoops, to the 5th. And then I want the square root of that. So the square root of e to the 5th is 12.18182, 12.182. So 4 minus that number so now 4 minus that number is negative 8.182. And this would be 4 plus 12.182. So this would be 16.182. And the question is, are both valid? In the original question, the answer is yes. Because if I punch in, obviously, if I punch in positive 16.182, take away 4 is a positive number. If you square it and then take the natural log of it, you're going to get 5. And on the other hand, if I use negative 8.182 and then take away 4, I'm going to take it back to the 12.182. It'll be negative, but before I take the logarithm, I'm going to square it. It's going to become a positive number again, and that's okay because of the square right there. Because of the square, it'll get squared before the logarithm happens, and therefore it's part of the domain. Now, here's the problem if you do what you shouldn't do here. Oh, let's bring the 2 down. We did it with the 1/2. But when you do it with the 1/2, if you left it there, it's a square root, and you end up squaring both sides. When you square both sides, it makes things positive. You don't get 2 different answers. You don't have the possibility of getting 2 different answers if you square something. 5 squared is 25. Negative 5 squared is still 25, one answer only. But when you take the square root of 25 and you're solving, when you're solving, you want all the possible solutions because you're taking the square root. There's a possibility that both might work. When you bring the 2 down, you're taking away the square root aspect. This is still valid work, but you're going to lose an answer. 5/2. So now when you exponentiate both sides, you're going to get x minus 4 equals e to the 5/2. And guess what e to the 5/2 is? It's the square root of e to the 5th, but it's a positive only. So when you add 4, you're getting 4 plus square root of e to the 5th power. You're only getting this one answer. You're not getting both possible answers. So that's why you should leave it when you're solving here. The reason why I'm bringing up 100, I'm bringing it back into the fold. We didn't do it wrong. That is absolutely correct. This problem is starting with the square inside of the logarithm. That one isn't, because you certainly can start an argument saying, hey, 3 plus 2 natural log of x equals 10. Subtract the 3 like we did. 2 natural log of x equals 7. We divided by 2 and then used each side as a base for e. But what if I put the 2 up here? The natural log of x squared is equal to 7. Exponentiate both sides, e. So x squared is now e to the 7th. And then take the square root. And because you're solving, plus or minus square root e to the 7th, and walk away, the answer is no, that's not right. Because in the original problem, it's not natural log of an x squared. It's 2 times natural log of x. Even though they are equivalent in terms of what they will equal, the original question is not natural log of x squared. So if you plug in negative square root e to the 7th, that's undefined. But over here, because the problem starts with the square inside of the logarithm, it's okay to have negatives in, within the parentheses. It's just a matter, I'm going to say the words, what do you have and what do you want? Okay, you got to just be aware of those things.